Earlier this week, we discovered that a set of parallel lines will always have the same slope. That causes them to be increasing at the same rate, which is what makes them parallel lines so that they would never intersect. But today we're going to look at the relationship between the slopes of perpendicular lines. So on your handout on the left-hand side, we have three graphical representations that are in fact perpendicular lines. I'm kind of steering away from the directions on the paper for this part, so make sure you're just following along with me. On our first graph, we want to start by finding the equation of each line. So you'll notice that we have two titles for our lines. There's an A and there's an A prime. That just means that A is the original line, A prime is the new line after it's been created to be perpendicular to the original. So we're just going to start with our original line, which is regular A. We're going to write the equation for A. In order to write an equation, we need two things. An equation is in the form y equals mx plus b, where m is our slope, which we also call our rate of change, and then b is our y-intercept, where the line crosses the y-axis. For starters, we want to find our slope. Remember, to find slope, we need two pretty points, and then we would do rise over run, paying attention to what they're counting by on each axis. This is a rise of 1 and a run of 1, so it just has a slope of 1. I don't actually have to write 1x, that's simply x. And then now I need the y-intercept. This line crosses the y-axis at 0. I also don't need to write plus 0, therefore the equation is just y equals x. Now let's look at the relationship for A prime, which is our new line. Same process, we need to find both the slope and the y-intercept. In order to find the slope of this line, we need to identify two pretty points. Going from left to right, I would have to rise down 1 unit and run 1 unit. Therefore, this equation has a slope of -1. -1 times x is just -x. And then again, the y-intercept in the situation is simply 0. I don't have to write plus 0 because it doesn't affect the equation. So we have our two equations representing our two lines. One of them is y equals x, one of them is y equals -x. That was more of just practice writing our equations. We're going to dive deeper into what's happening to our slopes with our next representation whenever it has a more obvious change. I'm moving to the representation on the right of our first graph. We have two lines. We have B and then we have B prime. That apostrophe is read as the word prime. Where B is our original line, B prime is the line that is perpendicular to our original. And again, we want to write the equation for each line. So I'm going to start with the regular B. Again, I need to identify both the slope and the y-intercept. I notice that B is increasing whenever I'm looking at the line from left to right. So my slope is going to be a positive number. Identifying two pretty points, and then doing rise over run, while paying attention to what they're counting by on each the x and the y-axis. I notice that they rise 1 and run 3, which is a slope of 1 over 3. So I have y equals 1/3 x. Now I need the y-intercept. This line is crossing the y-axis at 5. That's a positive 5, so I would say plus 5. That means the equation of our line B is y equals 1/3 x plus 5. Now we want to find the equation of B prime. Similar process, I notice right away that this line is decreasing from left to right, which means I'm going to have a negative slope. I'm going to identify two pretty points. As a reminder, your pretty points might be in a different place than mine, and that's okay. We should still have the same rate of change or slope as each other. This time I'm rising down 3 units and running 1 unit. So when I do rise over run, that would be negative 3 over 1, which just simplifies to negative 3. So my slope is negative 3x. And then this line also crosses the y-axis at positive 5. So plus 5. I'm going to give you and your table group about 30 seconds to see if you see a pattern between the two slopes of each line. All right, let's come back together. I want to address the two changes that happened when comparing our slope from our original line to our new line. The first thing I noticed is that our original slope was positive, but our new slope is negative. That means that they are opposites of each other in terms of their sign. One is positive, one is negative. The sign changed, so we're using the opposite sign. The next thing that I noticed, I'm actually going to come back to my original ratio over here for rise over run. The ratio of rise over run flipped. Our original ratio was 1 over 3, but now, ignoring the sign, it's 3 over 1. Whenever we have a fraction flip, it's actually called reciprocals. So 1/3 and 3 over 1 are called reciprocals. So not only did our sign change, but we are now using the reciprocal of the original slope. So this is the pattern that's going to exist with all perpendicular lines. I'm skipping ahead just a little bit to the bottom of the page, and I'm going to address underneath number 2. The slopes are opposite reciprocals. Anytime that you have a set of perpendicular lines, their slopes will always be opposite reciprocals of each other. One will be positive, one will be negative, and then the ratio of rise over run will flip between the two lines. They will be reciprocals of each other. So just going backwards just a little bit, we addressed that parallel lines, the slope will always be the same. Perpendicular lines, our slopes will always be opposite reciprocals. I'm going to do one more example with you, but in order to prepare you for the problems that you're going to be practicing after this, I'm going to go about it in a slightly different manner. When I write my equation, I'm going to be writing it in point slope form and then converting to slope intercept. So let's look at C and C prime. Starting with my regular line C, I notice that from left to right it is decreasing, which means our slope is going to be a negative number. Identifying two pretty points and doing rise over run, I notice that I move down 2 units and I run 3 units. That's a slope of negative 2/3. So that means my M value is going to be negative 2/3. Then I can use one other ordered pair. I'm going to use this ordered pair right here, which is located at 3, 7. So I'm going to write the equation of a line that has a slope of negative 2/3 and goes through the point 3, 7. As a reminder, point slope form is y minus your y value equals your slope m times x minus the x value of the ordered pair that you were focusing on. So let's go ahead and write our equation for this line. I would say y minus my y value is 7. Y minus 7 equals my slope is negative 2/3 times x minus my x value is 3. That is the equation of the line in point-slope form. Now, if I were to convert that to slope-intercept form, I would have to distribute the slope to everything inside the parentheses and then move my -7 to the other side of the equal sign. But let's focus on C prime for now. So I'm going to do the same process for C prime. I'm going to identify the slope and then choose one ordered pair to write the equation in point-slope form. On C prime, I immediately notice that my line is increasing from left to right. That means I'm going to have a positive slope. Choosing two pretty points and doing rise over run, I notice that I rise 3 units and run 2 units. So my slope is 3/2, and then choosing an ordered pair to focus on, I'm going to choose this one. I have -2, 7. Now I'm able to write my equation in point-slope form. I'd have y minus my y value is 7 equals the slope, which is 3/2, times x minus my x value is -2, which means I can actually rewrite that because minus a negative turns into addition. So that would be x plus 2. So there's my two equations in point-slope form. Now, pointing out again, I'm going to compare their slopes. My original slope was -2/3. My new slope is 3/2. You'll notice that those two numbers are opposites. One was negative, one is positive, and you'll notice that the ratio of rise over run flipped. So they are actually opposite reciprocals. The reason that it's beneficial to know that is we could actually create a perpendicular line from an original line by making a slope that is the opposite reciprocal of the original. So moving over to the right-hand side where you're going to be practicing, I just want to reiterate how that would be possible. Number 1 says write the equation of a line that's perpendicular to y equals 2x plus 1 and passes through the point 6, 2. If I know that my original slope is +2, then I can create my new slope by doing the opposite reciprocal of the original. Opposite as in the original number was positive, so my new number is going to be negative. Reciprocal as in flip the fraction. Well, 2 is not a fraction. I can turn it into a fraction by putting it over 1. So the reciprocal of 2 over 1 would be 1/2. Then you're able to write the equation in point-slope form using y minus the y value equals your slope times x minus the x value using the ordered pair that they gave you.